This video will cover how to estimate Pearson's correlation coefficient, or just Pearson's R, in R. So the basic idea of Pearson's R is that you have two interval ratio variables and you're trying to estimate a single number summary covering the strength of their linear statistical association. The example that we're going to be using as we work through how to calculate R is the 2016 wave of the General Social Survey. So the first thing that I'll do is just load that data. The core command that we use to estimate correlations in R is just COR for correlation, and then you put your independent variable followed by your dependent variable, basically like that. Within the GSS, the specific example variables that we're going to be working off of are first, on the independent side, father's occupational prestige, which is PA-Pres10, and our dependent variable is going to be the respondent's prestige score, which is Pres-G10. Now, if you just put those into the core command and run that, you're going to see that you get an NA value right there, as you would perhaps not expect. The reason for that is that at least one of these two variables, and probably both, have some level of missing, and the core command forces you to make a determination about what to do with those missing values. And if you want to see exactly what your options are, you can use the question mark and then core to pull up the help file for the correlation coefficients. And you can see there's a discussion right over here. What you're specifically going to want to look through is the use optional argument, and that gives you several options that you can work through. Usually the default that most people will want is the complete obs, which requires that both variables have valid values. So it excludes missing cases on one variable or the other, as well as both. And to specify that, you would just type use equals and then open up some quotes and type complete.obs. And now if I highlight that and run it, you'll see that I get my correlation coefficient back. So after rounding, that's around 0.19, which indicates a kind of weak to moderate positive correlation between the two variables. So really that's all that you need to do to estimate Pearson's R, although it is worth showing you one other thing that you can do. So if you want to look at what's called a correlation matrix based on multiple variables that are all interval ratio at the same time, you can actually extend the core command pretty straightforwardly to do that. So just like before, we're going to use core, open up some parentheses, except now we're going to use the name of our data frame object, GSS, open up some square brackets because we're going to be pulling multiple variables from it, type a comma because we're going to be working on the column side of the GSS, and then use the concatenate command to start naming the list of variables in quotes. So we'll do father's prestige, which is PA-Pres10. We'll do mother's prestige, which is MA-Pres10, and then we will do respondent's prestige, which is Pres-G10. And just like before, we do need to make a determination about what to do with our missing, and so here we'll just use complete obs again, so use equals complete.obs, and now you can run it, and you'll see that R will create the correlations between all three of those variables together. So, for example, the correlation between father's and mother's prestige is right there. It's around 0.2898954. Between father's and respondent's prestige, it's 0.1980671, which it's worth noting is a little bit different than the initial estimate that we had for just the bivariate correlation. The difference is because in this command on line 8, we are also eliminating any missing value for mother's prestige, as well as father's and respondent's prestige, which changes the analytic sample a little bit. If you wanted to recreate the initial correlation that we got, you need to change the way that you're handling missing. And you can see right here, we could actually use the pairwise complete obs, which will only keep the cases that have valid values for specific pairs of variables rather than all three of the variables. So if I change it and estimate it that way, you'll see that we get right back to our initial value of 0.1879805 right there. And that's it.